Yes guys, so we are doing question number 3 here, which was incomplete. Let me now continue. So now up to this point we have just described that integration of this 1.t minus a t plus a by partial fraction. We obtained that the constant a and b, a was 1.2a and b was minus 1.2a. Then I have written down this in the two separate portions or in partial fraction. Now integrating them and putting the limits. So first, after putting the limits, the first integral I1, this is I2. I2 is divided into two parts by partial fraction. Now let me further explain this. This is a within bracket under root 5 minus root 2. Okay, plus. Now this is a upon 2. A upon 2. Now integration of this 1.t minus a is log of, let me take, this is log of t minus a, try to understand. This is also, we have taken a upon 2 common outside, so this is only log of t plus a. Integration of 1 upon t plus a is log t plus a. This is 1 upon t minus a log t minus a. Integration, now limits a root 2 to a root 5. Further, let me explain this. This is a within bracket, it is root 5 minus root 2 plus a upon 2. Now, after putting the limits, let me just putting the limits. Upper limit, this is log of 5 a root 5 minus a, that means a upon, or let me first write, still I am not putting the limits. This is log m minus log n. We know that log m minus log n is equal to log of m upon n. This is log formula. Okay, with the help of logarithm, we know that log m minus log n is log m upon n. This is log t minus a upon t plus a. This is nothing but t minus a upon t plus a. Okay, and then limits we have to apply. So these limits are to be applied now. Okay, this was the, now putting the limits here. So this is a within limit, let me write under root 5 minus root 2 plus a upon 2. This is nothing but log of, now here upper limit. So this is a root 5 minus a common, and the denominator also a will be common, so a cancel out. Finally it will be root 5 minus 1. I'm sorry, this is root 5 minus 1 upon root 5 plus 1. Okay, and this is minus sign. Now lower limit, it will be log of, putting the lower limit, this is a under root 2 minus a, that means root 2 minus 1 upon root 2 plus 1. Again, this is log m minus log n, log m minus log n, log m upon n. Let me further solve it. This is a root 5 minus root 2 plus this is a upon 2 log of, now here it is the root 5 minus 1 upon root 5 plus 1 into, now try to understand, this is log m upon n. Now this is m upon n means this is in the denominator and this will come in the numerator. Why? Because if a upon b is divided by c upon d, we know that this is a into d, or let me write a upon b into d upon c. It is nothing but a into d upon b into c. Okay, this is why this will be under root 2 plus 1 come in the numerator and divided by root 2 minus 1. This is the value of this log m upon log n, log m upon n, that means log m minus log n, like this formula. This is log m minus log n means log m upon n, this value which come in the reverse order. Okay, now let me take this here. So finally, what do we obtain? This is a within bracket root 5 root 2 minus sign plus a upon 2 into log of. Let me now further solve it. If I rationalize, so let me multiply root 5 minus 1 by root 5 plus 1. If I multiply, and this is then root 5 plus 1 into root 5 plus 1 means whole square. In the denominator we have multiplied by root 2, root 5 plus 1 and root 5 plus 1, okay, of this. Second one, let me rationalize this. This is root 2 plus 1 into root 2. Yeah, this is root 2 plus 1. I have to multiply this by root 2 plus 1 divided by this is root 2 minus 1 into root 2 plus 1. No change. What we have done, to multiply by root 2 plus 1 in the numerator and denominator, this will be 2 minus 1 in the numerator, because a minus b, a plus b is a square minus b square. Similarly, in the numerator, this is under root 5 minus 1, root 5 plus 1, that means a square minus b square, a minus b, a plus b. So that will be, let me again put it, this is root 5 minus root 2. Now here it is plus a upon 2 log of, now it will be 5 minus 1 divided by, this is root 5 plus 1 whole square into, in the numerator we are having root 2 plus 1 whole square upon this is 2 minus 1. Okay, so this is only 1 in the numerator, this is 4 here. So further let me solve it. So it will give us then, let me further resolve it, and it is giving us a within bracket and root 5 minus root 2 plus say a upon 2 into log of, okay, now this is 4 into root 2 plus 1 whole square upon this is 1, no change, this is only under root 5 plus 1 whole square of everything. If I make 4 also written as 2 square, so square of all the 3 values, so we can write it as a into root 5 minus root 2 plus a upon 2 into log of. Now it can be written as 2 into root 2 plus 1 upon root 5 plus 1 whole square, no change, because the square of this denominator, square of numerator, and 4 can be written as 2 square, so square of this whole. Now log n, you know the log of m whole power n is equal to n log m. So this 2 will come in the, okay, multiplication of log. This is a into root 5 minus root 2 plus this is a upon 2 into 2 log of, this 2 has come before, this 2 root 2 plus 2 divided by root 5 plus 1. Alright, so this is the final 2 to cancel out. Now a can be taken outside, now a common, a, this is only a left. So this is root 5 minus root 2 plus log of, now 2 root 2 is root 8, can be written as 2 plus root 8, because the square root of 8 is 2 root 2 upon 1 plus root 5, okay, 1 plus root 5. This is the value which we have obtained here. What is the answer? Okay, this is a into root 5 minus root 2, a is outside common, and it is plus log 2 plus root 8 upon 1 plus root 5. Here same answer is obtained, hence it is proved the length of the arc, hence proved. This is question number 3 we have done. Now let me take next question, question number 4 now. Now let me see what is question number 4. What is question number 4 talk about? Okay, so question 3 is completed. Let me take now question number 4. So fourth question is, let me see it. Okay, so question number 4, what does it say? Now it says prove that if S be the arc of the curve, S, we always denote the symbol or take length of the arc as S. S, the arc of the or length of the arc of the curve here are equal to A sec alpha. Okay, where R is expressed in alpha, a third parameter. Theta is also expressed in tan alpha minus alpha, means alpha is parameter here. Means both the polar coordinates R and theta are expressed in terms of a third variable, or this is parameter. So variable parameter we have taken here alpha. So alpha is a third parameter. Okay, so here the parametric equation here, but in terms of polar coordinates. So where alpha is variable parameter, all right, measured from the initial line to a point P, up to point P. So let me take the vector, the curve on the curve, and if A be the area bounded by the curve, the initial line and the radius vector to P, then 9A square equal to, so let me write it here. First we are given the curve. What is the curve here? Curve is first is R equal to A sec alpha. This is the first, and theta is also expressed in terms of alpha. This is tan alpha minus alpha. This is second equation. Now to prove, and S is length of the arc, okay, from initial line, that means let me take 0 to, or this is here R equal to 0 to alpha here, where is variable parameter and measured to, okay, and from the and which is measured from alpha is equal to 0 to alpha equal to, let me take a point A, because it is A here, a point P, okay, the radius vector of that may be alpha is equal to, radius vector alpha equal to 0 to alpha equal to A. So in terms of alpha, limits we have to find out. So limits are 0 to alpha. Okay. Then to prove that if area A is the area here, if A is area denoted by, okay, area between initial line and if A be the area bounded by the curve, the initial line and the radius vector to P. So A is the radius vector. So between 0 to A again, A is the area bounded by the curve, and if A be the area bounded by the curve, the initial line and the radius vector to P, then 9A square is equal to twice A. This is S cube. This we have to prove. So to prove that 9A square equal to twice AS cube, this we have to prove here. Okay. What is given? Very important point. What is that? That here parameter alpha is there. So solution, let me find out. Here R is, so we have to differentiate R and theta with respect to alpha. So differentiating first and second with respect to alpha. So we get, what do we get here? This is dr, or this is R here. I'm taking R like this. This is dr upon d alpha. What is that? It is equal to, from this one. So this is A into sec alpha is differentiated as sec alpha into tan alpha. This is the value of dr, d alpha, and d theta, d alpha is equal to tan alpha is differentiated as second square alpha, and alpha is 1 because we are differentiating with respect to alpha. Alpha is not constant, so alpha is differentiated as 1, second square alpha minus 1. Okay, now let me take this third equation. This is the fourth one. What is the, if S is the length, we have taken S length. So S is equal to, or let me take ds upon d alpha whole square. Ds upon d alpha whole square. Therefore, is given by dr upon d alpha whole square plus this is r into d theta upon d alpha whole square. This is value of ds upon d alpha. For this we have to calculate ds upon d alpha. Finally we will calculate after taking square root of this. dr upon d alpha is this. This is a into sec alpha or a square sec square alpha into tan square alpha. Okay, plus sign r here. It will be r square. R square is a square into sec square alpha. R square is, and d theta d alpha is square is this. So it is secant square alpha minus 1 whole square. Okay, so now let me take common here. What is common? Is a square into secant square alpha is common. So first is tan square alpha left over plus sign from this. It is sec square alpha, and it can be written as tan square alpha. Okay, so let me first write that what it is. This is okay, sec square alpha minus 1 whole square. Okay, now let me convert this further. A sec square alpha. Now this tan square alpha can be written as, okay, this is 1 plus tan square alpha, or if I open this whole, it will be, let me write, this is 1, sorry, sec square alpha minus 1. It is sec square alpha minus 1. Sec square alpha is, sorry, tan square alpha is sec square alpha minus 1. We have put from trigonometric identity. Tan square alpha is sec square alpha minus 1 plus whole square of this will be sec 4 alpha minus 2 sec square alpha, and this is plus 1. Now this plus 1, because plus 1 square, plus 1 and minus 1 cancel out. We are left with a into sec square alpha. Within bracket we have sec 4 alpha minus secant square alpha. So again, sec square alpha is common, so we will have a in, sorry, this is a square. I'm sorry, this is a square outside. So a square into secant 4 now, sec square alpha further taken common. It will be sec 4 alpha outside, because sec square alpha is already there, and if I take sec square alpha common, then it is sec square alpha minus 1. Now this is nothing but a square into sec 4 alpha into tan square alpha. Why? Because sec square alpha minus 1 is tan square alpha. What is integration of this? So, sorry, square root of this. Therefore, let me write it here. Therefore, ds d alpha is equal to square root of this whole. This is dr d alpha square plus r square into d theta upon d alpha whole square root of this. Now this value comes out to be this. So square root of this, let me write here. So square root of what? This is a square into sec 4 alpha into tan square alpha. It will give us a into sec square alpha into tan alpha. This is value of ds upon d alpha. Okay, ds upon d alpha is this. What is the length therefore? Therefore, the length is equal to length of the arc. Therefore, length of the arc from alpha equal to 0 to alpha equal to, let me take a here. So it is 0 to a length. Okay, it can be written as ds upon d alpha into d alpha. Now ds upon d alpha is this value. Then differentiating that, we get here s is equal to limit 0 to a. Okay, now this is the value a sec square alpha tan alpha. This is a sec square alpha into tan alpha into d alpha 0 to a. Now if I put tan alpha equal to something, now substituting tan alpha equal to t, let me take, let tan alpha equal to t, therefore secant square alpha into d alpha equal to dt. So I'm not changing the limit here. This is a into 0 to a I have put here. This is nothing but, or we can just convert this into, now limits here. If I change the put in place of alpha as a, so it will be tan a t equal to tan a, doesn't matter. So let me take the limits here, because we have to change the, we have to prove that equation. For that, no need of changing the limits. It will be t into dt, because this is sec square alpha, d alpha is dt, so this is t dt. Integration of this will be t square upon 2 into a is already there, limits. Okay, now putting the same value, which is nothing but t is tan alpha, it will be tan square alpha 0 to a. So let me take this is a into tan square a. Okay, because at 0 it is 0. So a tan square a. This is the value of s. So s comes out to be a into, sorry, it is a by 2, I'm sorry, 2 will come out, it is a by 2, a by 2, because 2 will come out, and this is this. So a by 2 tan square alpha, this is value of s here. This is second, third equation. Let me take this as third equation. So third equation is this. Now let me talk about what is area. So for area, we have to have, we know that area is what? So area of the curve from alpha equal to 0 to alpha equal to a is given by 1.2 0 to a, this is r square into d theta it is, but we have to take the limits from alpha, so it can be written as d theta upon d alpha into d alpha. With this d theta upon d alpha, we have to substitute, and r square is to be substituted. Okay, because this is basically formula is 1.2 r square d theta, but d theta is a function of alpha. We can write d theta upon d alpha into d alpha. D theta d alpha value is this, that we have to substitute here. Now let me substitute that here. Okay, let me write here. So finally, what do we get? Therefore, A is equal to area we are calculating. This is this value 0 to A. Now this 1.2 is there. R square is a square into sec square alpha, this from first equation, and d theta d alpha is sec square alpha minus 1, sec square alpha, this is secant square alpha minus 1 into d alpha. Okay, this is value of area. Okay, now let me further solve it. It will give us tan square alpha. Now here sec square alpha is tan square alpha. So it is 1.2 a square. Let me take outside 0 to a. Now this is sec square alpha into tan square alpha into d alpha. Now again putting tan alpha as t, taking or putting by the same method, then again we will convert t into tan alpha. Okay, or we are not changing the limits. Putting tan alpha is equal to t here, therefore secant square alpha into d alpha equal to dt. this value will be 1.2 a square 0 to a. It is t square now into dt, because sec square alpha into d alpha is dt, and tan alpha we have taken t, so this is t square only. The integration of this will be t cube upon 3. Okay, now again putting, before taking the limits, we have to put t tan alpha. It is a square upon 6 here, because 3 to the 6. A square, and t cube is tan, q alpha is suppose a. Now this is value of a. Now let me solve this a. So finally a we have obtained. A is equal to a square upon 6, and this is tan q alpha. Here it is tan square alpha. So in the tan we have obtained this. If I square this and multiply by 9, it will give us 9 into a square, therefore will be 9 into a square. A square is a4 upon 36. Square of this whole. A square is this square. Multiplying by 9, then it is a4, and 10, this is 6 alpha. So the square of a square is a4 upon 36 into 10 6 alpha. A4 upon 36 is 10 6 alpha into multiply by 9. What does it give us? It will give us finally 9 for the 36. So it is, let me first write it down. This is a4 upon 4 into 10 6 alpha. Okay, this is 9a square is equal to. Okay, now further let me summarize this. So this is a4 upon 4 into 10 6 alpha. Okay, but we have to convert this into S form. If I write it as a upon, okay, a upon 2, we have to make a upon 2. So this let me write here. So 9a square is equal to, if I write as 2a taken outside, and if I write it as a upon 2 into 10 square alpha whole cube. Is there any change? Why? Because this is 10 6 is there, 10 6 alpha. It will be a cube upon 8, but multiply by 2a, a cube and a will be a4, this is a4, and 2 upon 8 is 1.4, so same thing. Okay, so this can be converted into this. This is written like this. It is nothing but 9a square equal to 2a into this is s from third equation. Okay, now this is, let me take fourth equation. So from third and fourth, what we have done, this equation was changed into this into this. We can write it as a by 2 10 square alpha whole cube. Alpha or 8 doesn't matter, this is alpha here. Okay, or if we are taking a because upper limit was a, that can also be taken. So this is a here or a everywhere, this is a, but that is not given there. We can take alpha or a, doesn't matter. If limits are 0 to a, then it is a here, so it is a. Let me take a. This is also a here, but after putting the limits, here, this is a here, this is a. No, sorry, still it is alpha, but after putting the limits, 0 to a, then it is 10 square a. Okay, so this had me written like this. So this is what 2a into s cube from third. S is a upon 2 into 10 square alpha whole cube of this. That means s cube. So this we have to prove. Finally, this relationship which we had to prove, 9a square equal to twice a into s cube, and proved. Hence the relationship obtained. Hence proved. This is question number 4 we have done. Okay, now let me take next question. What is next question? Means question number 5 say, let me now check that. Question number now 5. Question number 5 says, let me check. What did you say? It says, show that the length of a loop of the curve this is 2, 0 to 1 dr upon under root 1 minus r6 square root of 1 minus r6. Okay, let me first write it down. This is question number 5. Cartesian form of the equation is given. So this is 3x square into y minus y cube equal to x square plus y square whole cube. Okay, we have to find so that the length of the arc, to show that length of the arc of this curve, length of the arc of this curve is equal to twice 0 to 1. This is dr upon under root 1 minus r6. This we have to prove here. Okay, it means this is in terms of r. We have to convert this into polar coordinates. This is Cartesian form of the equation. The curve is this. Solution, let me find out. To obtain this solution, first let me convert this into polar coordinates. So converting or transforming, let me take transform. So transforming this Cartesian form of the equation into polar form. What does it mean? So putting x equal to r cos theta and y equal to r sin theta, let me take. Okay, so this is transformation of Cartesian into polar coordinates. So x equal to r cos theta we have to substitute and y equal to r sin theta. So what we see here, this equation is symmetric to y axis. Why? Because x is even power, x is square, y is single power, y is cube. Y is not even power, but x is even power. This curve will be symmetric to